average rates of change. Now, at this point, we know how to tell whether we're dealing with a linear function or whether we're dealing with an exponential function. We also know that in a linear function, the slope is constant versus in an exponential function, it's always either increasing or decreasing, and it gets larger and larger and larger. Now, average rates of change is just another way to compare the linear function versus the exponential function. And in short, an average rate of change is just the slope. Okay? And specifically, it's the slope between any two points. So we're going to write this in a couple different ways. Let's say our points are x1, comma y1, and x2, comma y2. The first way we know how to find slope is we know that it's denoted by m, which actually, for the sake of average rate of change, I'm going to get rid of that because m is typically for a linear function versus we can do average rate of change for any function. So slope is where we're going to take our y2 minus our y1 over our x2 minus our x1. The other way that we've been known to say that is that it's the change in y over the change in x, which those are deltas, and they mean change. So change in our y values over change in our x values. Okay, and then one more thing before we move on from this is if you ever see a certain abbreviation. So average rate of change, average rate of change is kind of, you don't see it too often, but some people use AROC as average rate of change. It's kind of an abbreviation. Example 3. 2 social media websites open their memberships to the public. Part A, compare the websites by calculating and interpreting the average rates of change from day 10 to day 20. Now, we have to do this for both companies, so I'm going to kind of split my page, and I'm going to split it right here. And I'm going to do website A over here, and I'm going to do website B over here. Now, in order to do an average rate of change, we need 2 points. And they specifically said from day 10 to day 20. So if I'm dealing with website A, I'm going to go over to my table, and I'm going to grab day 10, and I'm going to grab day 20. And I want to find the slope, or the average rate of change. How much did it change from day 10 to day 20? In order to do that, I'm going to take my y values, or my members, and I'm going to find the difference. So 2150 minus 1400. Over that, I'm going to take my days, which is 20, minus 10. Now, essentially what you're finding here is you're finding how many members per day. Okay, so the change in the days was 10 days. So over the course of 10 days. Then I'm going to grab my calculator. I'm going to take 2150 minus 1400, which is 750. So you're looking at, okay, over the course of 10 days, I went up by 750 members, which is 75 members per day. Okay, that's pretty good. You're gaining 75 new members per day. Now, part B, we're going to do the same thing, and we have to do from day 10 to day 20. Now, this is a little harder because we're looking at a graph. Well, members are over here, days are over here. Here's day 10, here's day 20. So in order to find my members on day 10, I'm going to follow that up and then follow that over. Then I'm looking, it looks like it's going up by 300. So 300, 600, this is going to be 900. So I know on day 10, I have 900 members. And then day 20, I have 1,800 members. Okay, so same idea. I'm going to take my members. I had 1,800 members minus 900 members. And then the 18 corresponded with the 20 minus 10. So over the course again of 10 days, I take my 1,800 minus 900, which is 900, which is going to get me 90 members per day. Now, the other key here is it says compare. So I found the average rate of change for A. I found the average rate of change for B. So, well, what's going on? And I'd probably say something like this. So website B is gaining more members per day. And specifically, 90 minus 75, I think is like what, 15? So website B is gaining 15 more members per day than website A. And then we've compared. Part B, predict which website will have more members after 50 days. Well, we could try to find how many members they're going to have after 50 days, and we could also make a guess before we start that. So which one will have more members after 50 days? If I'm at 25 days, it looks like we've got 25 members. If I'm at 25 days over here, ooh, not even quite hitting the graph, but let's see. 18 plus 300 is 20. This is like 2,100. So they're getting close together, okay? But this is 25 days, and essentially I'm gonna, double that to 50. I don't really have to figure this out at all because these are like so close. I'm gonna guess it's gonna be website B. So we're going to guess, and then we might go figure it out. So I'm going to say website B because it's exponential. Okay, and what do we know about exponential growth versus linear growth? Well, exponential growth keeps getting faster, 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 faster until it almost, on the graph, it's going to look like it's almost a vertical line. It's not. It's just growing that fast. Versus if I look here, I'm pretty sure this is linear growth. So let's see. 1025 minus 650. This one up by 375. Okay, 1,400 minus 1025. This one up by 375. So this one to me looks linear versus this one is exponential. Well, exponential growth goes faster, faster, faster. Linear growth is just going to go up by 375, and then 375, and then 375. Okay, so this one is not really going up by that many members per day. This one just keeps getting faster and faster and faster. So predict which website will have more members after 50 days. Website B because it's exponential. And then we know exponential growth, okay, specifically growth, eventually is faster than linear. Okay, it might start out slower, but eventually it's going to be faster and it's going to be higher.